All right, here we go. So we're on 2.4b, exponential function manipulation. And this is all about being able to graph without a calculator. Because remember, there's calculator portions and non-calculator portions. And you should be able to identify some of the basic attributes of functions without a calculator, okay? So the first thing is to make sure you understand some of the basic transformation manipulations. Okay, that's yeah, that was hard. So here we have f of x equals 2 to the negative x, and we want to change it to g of x equals 2 to the negative 2 to the x. Okay, so when we're looking at these two, first thing foremost, they're already both transformations, right? The first one is a what of the original function of the parent function. Right. This one, what is f of x of the parent function? Anyone? Everyone? If you don't remember, you can look at your other notes and see what compared to your parent function, 2 to the x. It's a reflection over the what? Over the y-axis. So f of x is I'm going to write PF for parent function, reflection over the y-axis. If I know how to spell. I learned this morning that I forgot how to write, apparently. It feels weird, like, and this thing is already weird to write with, but my hand and I are not just... like, when you come back from summer. Yeah, you're like, what is this? Yeah. So it feels very weird. Yes. Shh, sorry. If the negative's on the exponent. No, but like if it's that means if it's negative, the negative is what makes it reflect. So if I have x minus 3 and x minus, that just should be right. Yes, yes. The negative is what makes it a reflection. All right, so so we're describing again what each one is. So on this one, it is a parent function reflection over the y-axis. What's happening to g of x compared to our parent function? It's actually the opposite of what you think. Remember, x's are liars, so it's a reflection over the y-axis, but it's also a horizontal shrink, compression, horizontal shrink or compression. So this is still a reflection over y-axis, but it's now a horizontal shrink, or if you want to write compression, it's just a longer word.
So what exactly is reflecting over the y-axis?
The exponential function. So our parent function, 2 to the x, right? It is normally looking like, right? But it's reflecting over the y-axis. That's the first one. And then it's going to, exactly, because the negative is going to make your...
Why are they all called the parent function then?
The parent function is the original. These are the transformations. So this is your PF, your P. It's the most basic, barest of it all.
Okay, so there's like a reflection of the parent function, not the actual parent function.
It's a reflection. The parent function is being reflected. All right. Wait. You're on the wrong one. All right. So, now we're just gonna fill in the table really quick. When you're filling in the table, you have options. You can just plug in and simplify, correct? Or you can apply transformation rules. I'm just gonna plug in and simplify. Is that cool with you? Yeah. That's the fastest way I can think of it. So here on the first one, we have 2 to the negative 2. We will have 2 to the, not negative, positive 2, because a negative times a negative is a positive. 2 to the positive 1, 2 to the 0, 2 to the negative 1, 2 to the negative 2. And that's going to give, exactly. So we have 4, 2, 1, 1/2, and 1/4. All right. So I'm going to go to negative 2, 4. I'm going to go to negative 1, 2. I'm going to, guys, 0, 1, 1/2, and a 4.
So if you have a copy of these notes, because I think I have a little one. I have, in my defense, I have example. I have example 3 and it's very similar.
They,
4.1. Yeah, is that part 2?
yes.
Do you have a part 2 or part 2?
It should have been in the red basket with all the rest of the stuff left over from last week.
That was just, there's a red basket, and then a red basket.
Yeah, there was assignments and then there was notes in both red baskets left. If not, then it'll have to be a moment for me in a second. All right. So when I get to a stopping point, I will figure it out, but I wish you guys would check for these things before I start. Anyways, here we go. All right, same thing here. Do we see how our parent function was reflected? So here's your parent function and it's reflected, okay? At this point, you should have a general idea of what most parent functions look like and where they begin, okay? So this one, it's going to be a horizontal shrink. So now we're going to do that one. So I have 2. My base is still 2 for all of them. That doesn't change. But what's changing here is I have -2 times -2, which is 4. -2 times -1 is 2. -2 times 0 is still 0. -2 times 1 is -2. And 2 times -2 is -4. So I'm 2 to the 4th is 16. 2 to the 2 is 4. 2 to the 0 is still 1. 2 to the -2 is 1/4. And 2 to the -4 is 1/16. Okay. So I can't graph -2 clearly, right? So I'm going to go to -1 and start at 4. 0's at 1. I'm going to be down here. And I'm going to get a little closer. And we're going to just do our very best to. I feel like I did pretty darn good. Okay, so you can see that compression on the horizontal axis. All right, it was further out. Now that it was compressed inward. Does that make sense now? All right. When you look at this function, their domain and their range are still the same, right? Neither one was altered. The domain for all exponentials is from -infinity to positive infinity, and the range here, because I still have that invisible boundary line at y = 0, is still from 0 to infinity. How do you feel about graphing without a calculator? Is it doable?
What factor determines whether it's a concave up or down?
So imagine if this was to continue outward, it would be concave up. So like if I was to make some type of parabola, think about your contact. A contact is concaved up when it's because you're putting, right? So think about the concavity of that.
But like, which factors does it be? Like which number or variable?
You're not really looking at that variable, you're looking at the shape of the graph.
Okay. So you
Yes.
can't figure that out just from looking at the equation?
If you understand what the shape is going to look like, yes, you can.
Oh.
There's a horizontal axis.
There's a horizontal axis because there's no way that with this model that anything will ever actually equal 0. All right.
Oh my god.
Example number 6. So here we have show that the function g of x equals 2 to the -2x can be written in the form of h of x equals bk to the x. Someone asked me earlier. Who asked me this? Caroline? Was it you?
Yeah.
Okay. I was like, wait, someone asked me this. We're going to be using our power property. So we're using the power property of exponentials. Okay. Basically, the power property is saying that if you're multiplying 2 exponents, that means that they can be separated by multiplication. Okay. So for example, here we have 2 to the -2x, and it wants me to rewrite it as a singular, what do you call it? Function in transformation, or not in transformation form, but in your typical a times b to the x format, right? So I can rewrite this by separating. So g of x equals 2, and I'm separating the variable, the unknown. And the only thing I have to do to separate is use parentheses.
Oh, wow.
Now, could I do that in reverse? Yes, but
We don't put it on the exponent, was the exponent on the outside?
No, you're only putting the unknown, the variable on the outside. So if you look here at the model, h of x equals b to the k. K is your coefficient, x is your variable, your unknown. Okay, so then once I separate it, now I can simplify this. And when we simplify it, it wants us to call it h of x. So what is 2 to the negative 2? 1/4 to the x. Okay, and so it says describe the transformation of the y-intercept from the parent function 2 to the negative x. So when I'm looking here, is there going to be any change in my y-intercept? No. Why is that? There we go. So we would write our y-intercept on f of x, which is already at 0, 1, our parent function, this guy right here. F of x is 2 to the negative x is 0, 1. And it does not move. Not move for any of the transformation. Doesn't move on g of x or h of x. Yep, they're just written two different ways. These are equivalent functions. Okay, and the reason being is because anything to the 0 power is 1. Unless I have some type of vertical shift or horizontal shift, it's not going to change that fact because all I'm doing is multiplying by 0. Okay. Okay. All right. Equivalent functions, yes. All right, so what I would like for you to do on example number 7, you're going to graph f of x equals negative 2 to the x and graph negative 2 to the x plus 3. Okay, keep it in mind, what are the transformations that took place? So now my negative is no longer on my power, but it's on my leading coefficient. What am I doing now? What does that look like from my original parent function? And now I am adding onto the function as a whole. What is that going to look like? Okay, so I'm going to give you about 2 minutes to figure out your graph. If you don't feel confident in your graph, I strongly encourage you to use a pencil so that if you do make a mistake, that you can quickly erase and fix. All right, so again, we're coming from the knowledge that we know that our parent function 2 to the x, it originally looks like this guy, right? And now what am I doing to it? How am I manipulating that? All right, so while y'all do that, I will print Okay, so when you look at negative 2 to the x, can you tell me the transformation that took place? What was the transformation? It did what? If I have negative 2 to the x, what does that look like on the graph?
Or no, to the side too, like this way too. No, right.
Thank you. It's a reflection across the x-axis. I was a little concerned there. So this guy right here, compared to our parent function, is a reflection across the x-axis. Because there's a negative in the coefficient. So when I reflect across the x-axis, that means instead of being at 0, 1, I'm now at 0, negative 1. Does that make sense?
Mm-hmm.
So instead of being at 1, 2, I'm now at 1, negative 2. Instead of being at 2, 4, I'm now at 2, negative 4. It's the same. Your parent function numbers are the same thing that are reflected over the x-axis, okay? Because this negative right here is causing me to reflect over the x-axis. So now I'm doing this number. Guys, pretend that this is like the best. There we go. So now my 4f of x, where's my y-intercept? Is at 0, negative 1. All right, now we're going to look at g of x. So g of x is saying, okay, now you've reflected. After you reflect, I now need you to do what? I need you to now move up 3. Because my parent function is at 0, 1, but also if I just plug 0 in, 2 to the 0 is 1, and then 1 times negative is negative 1.
So it's not negative 2 to the power, it's 2 to the power. And then
Yes.
I was gonna leave that.
Yeah, it's whatever your x is. So it'd be 2 to the 0 first, exponents first, and then multiply. PEMDAS.
Okay, I thought it was connected to it, like I thought it was negative, but it's more like minus.
Because there's no parentheses there, I must follow PEMDAS. Okay. All right, now we're doing g of x. So g of x says I'm taking this blue and now I'm shifting everything up 3. So all of these points are going to shift up 3 units. 1, 2, 3. 1, 2, 3. 1, 2, 3. Does that make sense? Okay. Now, the key thing here to also note is that, again, you have this horizontal asymptote at y equals 0. That also shifts up 3 units. Your horizontal asymptote also shifts. So now my horizontal asymptote is at 3. So now my horizontal asymptote is at y equals 3. So my function is doing this number. I feel like that's fairly good.
Actually not bad, yeah.
Thank you. Thank you. So now the y-intercept for g of x is where? At 2. So we're at 0, 2. Okay. So what were our descriptions here? So what happened with, this is our parent function and its barest. What did we say took place with f of x? It was just reflected across the x-axis, over, across, same thing, right? Across x-axis.
Oh, so it's just telling us that we don't actually know that. That we just know that.
Your parent function is always whatever the base is, just to the x power.
Okay.
So if it was 3x plus 5, your parent function is 3 to the x. Okay. So g of x, what happened to g of x again? Compared to its parent function, what do we do? I have no clue why these are so far apart. I told y'all I forgot how to write. I'm struggling with writing. I admitted it, and it's a vertical and it's shifted. Like my T's and my F want to be the same. 3 units up. Okay, I'm gonna practice. I'll be better writing by Friday. But my writing is not here. All right, Yes? Does it make more sense? Feeling okay about it? All right, here you go. Another one for you to try. So it says f of x equals 1/3 to the x on the grid at the right. That's what we're graphing. So your parent function now is 1/3 to the x. Okay, how do I know it's the parent function? There are no transformations taking place. Does that make sense? It's just the base and the variable power. Yes, base, variable power. Okay, on the grid. Then use the graph to obtain 1/3 x minus 4 plus 2. Okay. So again, you're practicing without a calculator. If you do not practice, we will complete this. Your due now for tomorrow are going to be examples number 9 and examples number 8. FYI, what are the due now for tomorrow? Examples 9 and 10. See you mañana. Finish the assignment. All right, so really quick, we had 1/3. So when we are looking at our 1/3 to the x, thinking about it this, so if you're looking just graphically, let's start with -2. So if I have 1/3 to the -2, that means the negative tells me that I am reciprocating my 1/3, so it becomes 3/1. And then now 3 to the second power is going to give me 9. So when I go to -2, I'm actually going all the way up to 9. Following that same thing with -1, I would reciprocate, plug in 1, and now I'm going to be at 3. Okay, so keep it in mind, negatives are going to cause your number to reciprocate, to flip. All right, anything to the 0 power is going to be 1. And then 1/3 to the 1 is 1/3. 1/3 to the second is 1/9. It's gonna be as close as a little closer. Language. And we're going to go. Okay. All right. So the y-intercept here is 0, 1. Now, notice here it's saying that for g of x, we have x minus 4 plus 2. So remembering, how does that affect our points? What is it telling us to do? Okay. So x minus 4 is telling us that we are going to describe our transformations, right? If we're looking for our y-intercept, that means we're plugging in 0. So when we're looking for g of 0, I'm plugging in 1/3 0 minus 4 plus 2. Okay. So where am I going to be at? What is this going to cause me to shift to? So again, that negative is telling me that it's being reciprocated. So it becomes 3 to the 4th power. 3 to the 4th power is a fairly large number. It's 91, right? It's 81, sorry, 81. And then I'm going to add 2. So this becomes 81 plus 2. So g of 0 is now at 83. That's just doing it mathematically. Now, looking at it here as far as transformation, what's taking place? So we have 1/3 x minus 4 plus 2. So x minus 4 is telling me that I'm shifting all of my points that I have on my parent function to the right. So the x minus 4 part, that is going to be a horizontal shift. Right. 4 units. Okay, the plus 2, that plus 2, that's going to be a vertical shift up 2 units. So remember, for x's, they're liars. So we thought it was probably going to the left, but it's actually going to the right. And our y's could just do what they do. So we're taking this point and we're going to shift it right 4 and up 2. So we're going to go 1, 2, 3, 4, 1, 2. Okay, same thing here. We're going to take this point and we're going to shift it right 4 and up 2. 1, 2, 3, 4, up 2, 1, 2. On my desk. And then we're going to shift the same with all these points. So we're going to take this little guy, go 1, 2, 3, 4. And then we're gonna go up 2 units. The one on the silver hook. It should be like a. So now we're doing something like this. Okay, notice that here we had an asymptote at y equals 0. Our asymptote is now at y equals 2. And I'm not touching 2. I'm still approaching it. Okay. So the domain and range are changing clearly. So the domain and range for g of x, the domain is still -infinity to infinity, but the range here, your range is now from 2 to infinity. Okay. All right. All right. So for tomorrow's due now, you're going to have example number 9. So you're going to describe the transformation of the parent function of 2 to the x. So let's see how that goes. And then here, you're going to also describe the transformations for A, B, C, and D. All right. Thank you.